This is exercise 7.8, perpendicular distance. In this exercise, we look at the formula which lets us calculate the perpendicular distance of a point to a line. Now, if I have this point here, x1, y1, and I want to work out the distance from this point to this line, I mean, we can take many different distances, say across here, or this distance across here, but neither of these distances are the shortest distance. The shortest distance will be the perpendicular distance of the point to this line down here. So whenever we talk about the distance of a point to a line, we talk about the perpendicular distance of the point to a line because that is the shortest distance between the point and the line. So the formula for working out the perpendicular distance from a point x1, y1 to the line ax plus by plus c equals 0, notice this line is in general form, is given by this formula. And the formula is D equals the absolute value of ax1 plus by1 plus c, absolute value of that, over the square root of a squared plus b squared. And the a squared plus b squared, a and b are the coefficients of the x and the y in the original line. And basically you write down the equation of the line, and what happens with x1 and y1 is that you substitute in the point into the x and y bits of that line. Now you'll see that when we do a few examples below. So the first question is, now also before I do that, you'll notice that we take the absolute value of the numerator here, and the reason this will sometimes be positive or negative depending on which side of the line that the point is. So for example, I might have my line here, and if my point is over there, I might get a positive value for this numerator, but if my point was down here, I might get a negative value, or vice versa. Okay, so later on in some examples we'll be asked to show whether two points lie on the same side of the line or on opposite sides of the line, and you'll be able to tell if, when you work out the numerator, if you're getting either both positive or both negative values, they would be on the same side of the line, or if one was positive, one was negative, you'd get opposite sides of the line. But we'll discuss that later in example 2. Now in example 1, you're asked to find the perpendicular distance of the point -3, 2 from that line 5x plus 12y plus 7 equals 0. So we write out the formula D equals absolute value of ax1 plus by1 plus c over the square root of a squared plus b squared. And now we can substitute in our values, and we put that it's 5 times, so that's our line, that's our ax plus by plus c equals 0. But we substitute the x and y values for these values here. So the x1, y1 is -3, 2, it's your point. So we go 5 times -3 plus 12, which is this, times the y value, which is 2, plus 7. All of that over the square root of, now that's a and that's b, so it's square root of 5 squared plus 12 squared. And working that out, we get the absolute value of -15 plus 24 plus 7 over the square root of 25 plus 144, which becomes 169. So that becomes the absolute value of 31 minus 15, which is 16, over 13. Absolute value of 16 is 16, and the square root of 169 is 13. So your answer is that the perpendicular distance of the point -3, 2 to that line is 16 over 13, or 1 3/13 units. Okay, so that's our first example. In example 2, we're asked to show that the points 3, -5 and the point -1, 4 lie on opposite sides of the line 2x minus y plus 3 equals 0. So what we're going to do, we're going to do the distance from 3, -5 to the line, 2x minus y plus 3 equals 0. So I'll just do that first. So distance is absolute value of 2 times, then we put the x value in here, 2 times 3, minus in front of the y, we've got a 1, so it's 1 times, and the y1 here that we substitute is -5 plus 3 over the square root of a squared plus b squared, and a and b are the coefficients of x and y, so it's over the square root of 2 squared plus 1 squared, okay? Which is, actually, it's 2 squared plus -1 squared, but when you square the -1, you get +1 anyway, so we'll just leave it like that. So we get absolute value of 6, and this becomes +5 plus 3 over the square root of 5, so that becomes absolute value of 14 over the square root of 5. Now, because that is positive, we'll just leave that at the moment because we've got a positive value here, okay? Then we can look at the distance from the point -1, 4 to this line, 2x minus y plus 3 equals 0. So distance, we'll call that one distance 1, distance 2 is, so we go 2 times, substitute in this x value here, so it's 2 times -1 minus 1 times the y value there is 4 plus 3 over the square root of a squared plus b squared, so it's over 2 squared plus -1 squared. Okay, and then we get 2 times -1 is -2, then minus 1 times 4 is -4 plus 3 over the square root of 5, so we get absolute value of -6 plus 3 is -3 over the square root of 5. Now, because what's in the absolute value sign here is positive, and what's in the absolute value sign here is negative, we know that that points A and B lie on opposite sides of the line. And so ignoring absolute value signs, we can say, well, that equals -3 over root 5, and this one equals 14 on root 5. And so we can say, as these have opposite signs, therefore points, so we can say, as these have opposite signs, sorry, I'll just remove that. So as these have opposite signs, therefore points A and B lie on opposite sides of the line. 2x minus y plus 3 equals 0. Okay, so what you can probably do is actually don't put the absolute value signs in the beginning, or you can put them in there and then say, ignoring absolute value signs, you can see that these have different signs. One's positive, one's negative, therefore the points lie on opposite sides of the line. Now, if both of these were negative, they would lie on the same side, or if both these points, or both these distances here were positive, they would also lie on the same side of that line. Okay, now in example 3, we're told that the perpendicular distance between the point x -1 and the line 3x minus 4y plus 7 equals 0 is 8 units, and we have to find 2 possible values of x. So what we're going to do, we're going to set the formula up. First I'll write the equation, and it's d equals absolute value of ax1 plus by1 plus c over the square root of a squared plus b squared. I'm just going to write down what I've got here. My points, x1 is x and y1 is -1, and we know that a is 3 from this equation, and that b is -4, and you can see that c here is 7. Okay, and we know that the distance is 8. So substituting this all in, we've got the distance is 8. So we're basically writing the equation of the line. We go 3, and then we substitute in here what x1 is, and it's x. And we go minus 4 times whatever y1 is, which is -1, plus c is 7 over the square root of a squared plus b squared, so it's over the square root of 3 squared plus -4 squared, which gives us that 8 equals the absolute value of 3x. Now minus 4 times -1 is plus 4, and then we've got plus 7 over the square root of 9 plus 16 is over the square root of 25. So we get 8 equals absolute value of 3x plus 11 over 5. Now we can multiply both sides by 5, so we get 8 times 5 is absolute value of 3x plus 11. In other words, absolute value of 3x plus 11 equals 40. So now we've got two cases here to solve. So either we've got that 3x plus 11 equals positive 40, or we've got that 3x plus 11 would equal negative 40. So solving this first one, we get that 3x is 40 minus 11, which is 29. Therefore, x is 29 over 3, which means that x is, it's 9 and 2/3. Or we've got that 3x equals negative 40 minus 11, which is negative 51. Or that x is negative 51 over 3, which happens to be negative 17, I think. Okay, so we get that x is either 9 and 2/3 or 29 over 3, or that x is negative 17. Okay, now we can just check those answers. So if we get that x is negative 17, 3 times negative 17 is negative 40. No, it's not negative 40, it's negative 51 plus 11 is negative 40. Absolute value of negative 40 is 40 over 5, which is 8. And over here, if x is 29 over 3, we get that 3 times 29 over 3 is 29 plus 11. Oh, I can do it up here. So 3 times 29 over 3 is 29 plus 11, which is 40. Absolute value of 40 is 40 over 5, which is 8. So yes, those answers appear to be correct. So therefore, x equals 29 over 3 or negative 17. Okay? And that's the solution to that question. And what these two values of x just indicate is that the points, more than likely, the points will be, one point will be on one side of the line. Let's say the line, if we look at it, if we look at this line, it's got a positive gradient. So one point might be 8 units on this side of the line, and the other point will be 8 units on the other side of the line. And that's why we're getting here that, a positive and a negative value more than likely. Okay? Okay, now in the next few examples, we're going to look at the intersection of a circle and a straight line. Now, when you're using perpendicular distance formula, or the perpendicular distance of a point from a straight line, you can apply it to these questions with circles and straight lines. So there are 3 possibilities when we have a circle and a straight line. The first possibility is that that line will not cut through that circle. Now, if that line does not cut through that circle, then the perpendicular distance from the center of the circle to the line would be greater than the radius, than what would be just the radius of the circle. So if the perpendicular distance from the center of a circle to a line is greater than the radius of the circle, so that's the distance from the center to the line, and this would be the radius just up to there, then the line will not cut the circle. Okay, that's our first possibility with a circle and a line. The second possibility with a circle and a line, I'll just put this so that you can actually see the next 2 possibilities. Okay, I'll just focus this. So the first possibility was that the line does not even cut the circle. The second possibility is that the line is actually a tangent to a circle. So if the perpendicular distance from the center of the circle to the line is actually equal to the radius of the circle, now remembering that always a tangent to a circle is perpendicular to the radius at the point of contact there. So if the perpendicular distance from the center of a circle to a line is actually equal to the radius of the circle, then this line will be a tangent to a circle. Remembering that this line is a tangent, and a tangent cuts or touches the circle at just exactly one point there. Now the third scenario will be that our line will cut through the circle. Okay, and if it cuts through the circle, it'll touch it at 2 points, and this will occur if the perpendicular distance from the center of the circle to the line is actually less than the radius. So we can see here the perpendicular distance from the center of the circle to the line is actually less than the radius. The radius is much longer here. Okay, and if this happens, then the line we'll cut the circle in 2 places. Okay, so these are the 3 possibilities of the intersection of a circle and a line. Either the line will not cut the circle at all, and that will occur if the perpendicular distance from the centre of the circle to the line is greater than the radius. Your second scenario is that the line will be a tangent to the circle, where the perpendicular distance from the centre of the circle to the line equals the radius. And the third scenario here, it will be that the line will cut the circle in 2 places, and that will be if the perpendicular distance from the centre of the circle to the line is less than the radius. Okay, we'll now do an example on this. Okay, and here is example 4. And example 4 is prove that the line 6x plus 8y plus 20 equals 0 is a tangent to the circle x squared plus y squared equals 4. Now we start off by saying, well, x squared plus y squared plus 4, equals 4 is a circle with centre 0, 0 and radius equal to 2. Okay, now the distance from the centre of the circle, so from the centre from 0, 0, so we want to work out the distance from, or the perpendicular distance from 0, 0 to the line 6x plus 8y plus 20 equals 0. We're going to work that out now. Okay, so D equals absolute value of ax1 plus by1 plus c over the square root of a squared plus b squared. So that perpendicular distance is 6 times, absolute value of 6 times. Now, the centre of the circle is your point x1, y1. So 6 times 0 plus 8 times whatever y1 is, which is 0, plus c is 20 over the square root of a squared plus b squared. A is 6, so it's 6 squared plus b is 8, so 6 squared plus 8 squared. And we get that the perpendicular distance is, we get 0 plus 0 plus 20. So it's the absolute value of 20, which just happens to be 20 over the square root of 100, because 36 plus 64 is 100, and that's just 20 over 10, which happens to be 2. So that means that the perpendicular distance from the centre of the circle to that line equals the radius of the circle. So the perpendicular distance, perpendicular distance from centre of circle to the line 6x plus 8y plus 20 equals 0 is equal to the radius of the circle. In other words, D equals R, which equals 2. So therefore, the line 6x plus 8y plus 20 equals 0 is a tangent to the circle x squared plus y squared equals 4. Okay? Now, if you were asked, I'm going to put a similar question here. Okay, so example 5, I'm using the same line. Okay? And the question here is to prove that the line 6x plus 8y plus 20 equals 0 does not touch the circle x squared plus y squared equals 1. So we're going to do the same thing here. We're going to say that x squared plus y squared equals 1 is a circle with centre 0, 0 and radius equal to 1. Okay, now we're going to work out the perpendicular distance from the centre of the circle, so from 0, 0 to the line 6x plus 8y plus 20 equals 0. So D equals absolute value of ax1 plus by1 plus c over the square root of a squared plus b squared. Now we've already done this question earlier, but I'll just do it again. Remembering our point is x1, y1 is 0, 0. So when we substitute our x1 and y1 here, we get 0 there, 0 there, and we just get 20. So we get absolute value of 6 times 0 plus 8 times 0 plus 20. So it's exactly the same calculation as before, over the square root of 6 squared plus 8 squared, and we end up with 20 over 10, which happens to be 2. So now you can do a quick sketch if you want. You can say, well, this is my circle. This would be my circle x squared plus y squared equals 1. But the perpendicular distance of the centre 0, 0 to your line happens to be 2 units. So I'm not going to draw exactly where this line would be, but if I just have a quick look at it, 6x plus 8y plus 20 equals 0. If I just rearrange it, 8y is negative 6x minus 20, so y is negative 6 on 8, x minus 20 on 8. So it's got a negative gradient and a negative y-intercept. I would say that the line sort of goes like this, and the distance from the point to the line happens to be 2 units. Perpendicular distance from the centre of the circle to the line is 2 units, but the radius of the circle is 1 unit. So here I can say that, well, D is greater than R, so the perpendicular distance, from centre of circle to line is greater than the radius. Therefore, line does not cut the circle. And I've drawn that in the diagram up there. We can see that we've got a radius of 1, perpendicular distance from the centre of the circle to the line is 2, and clearly the line does not cut the circle. Okay? And then there's always the third scenario where, and I can quickly just draw. Now I've quickly drawn the scenario here that proving that, for example, the same line again, that it cuts the circle x squared plus y squared equals 9 in 2 places. Now we know that the circle x squared plus y squared equals 9 is a circle with centre 0, 0 and radius 3. And we also know from doing examples 5 and 6 that the perpendicular distance from the point, from the centre 0, 0 to this line is 2 units. So if I'm saying, well, the perpendicular distance from the centre of the circle to the line is 2 units, but the radius of this circle happens to be 3 units, then the line would cut, we can see that it cuts the circle in 2 places. So we can say, well, that D is less than R, because we know that the radius is 3 and the perpendicular distance of the point to the line is 2, so therefore the line cuts the circle in 2 places or in 2 points. Okay, so that question can be asked 3 ways. Show that the line does not cut the circle, show that the line is a tangent to the circle, or show that the line cuts the circle in 2 points. So you could be asked any of those 3 methods. I suppose another way of doing this question here to show that it cuts the circle in 2 points might be to try and solve it simultaneously and to show that you've got 2 solutions, okay? But that is another way, but I think that would be quite long and it would get quite messy. I mean, we can have a go at it now. If I've got x squared plus y squared equals 9, and I've got that 6x plus 8y plus 20 equals 0, I'd have to make y the subject of the formula here, so I get that 8y is negative 6x minus 20. You could divide everything by 2 here. 4y is negative 3x minus 10, so you'd get, now dividing everything by 4, you get y is negative 3/4 x minus 10 on 4. And then you'd have to go and substitute that into x squared plus y squared equals 9. Look, that is going to get very, very long and messy. I'll just start it, but I'll just show you that it will get very long and messy. This is a perfect square here, so you would have to expand. 3 over 4x all squared is 9 over 16x squared. Then you've got to go minus 2 times that. So you'd get minus, I think it's minus 60 on 16, and then plus the last one squared, you'd get 100 over 16. But this is an x there, equals 9. So you can see that it is getting a little bit messy. You'd have to multiply through by 16. As I said, it's getting messy. I mean, we'll just have a go here. and hopefully I'm not even making a mistake. I mean, I could have made a mistake. I'm doing this fairly quickly without a calculator. So I'll just check it. So I'm getting 25x squared minus 60x minus 44 equals 0. You've then got to solve that by probably more than likely the quadratic formula. So you can see this is quite long and messy. It really would be much better to go up and use this top method here. Okay, the idea is not to solve it simultaneously. It would just take too long. I mean, I'm just doing it here, but it will just take too long. And the idea is that you would know to use the perpendicular distance from the point to the line instead of doing this long, messy method down here, which I am not going to complete. But if I did complete it, provided this bit under here is not 0, we will definitely get 2 solutions. And it's not going to be 0 because we've got 3,600 plus, I think, 4,400, and whatever that ends up being. I think it ends up being plus the square root of 8,000 over 50 times 44 and whatever that is. Okay, so there are definitely 2 solutions there, but that just really does take a lot of time and it's not necessary for this question. Okay, so now I'll just set the questions in this exercise for you to do. Okay, if you could now do exercise 7.9, questions 1D, 3D, 7, 8, 9, 12, 14, 16, 17, 18, 19 and 20. 20 is a little bit involved. You've got to solve a few simultaneous equations and you've got to work out some heights of triangles. Okay, so there's a little bit there. I suggest you sketch, definitely sketch question 20 before you attempt it. Okay, that's the end of this video.